Hello everyone, welcome to AP Calculus with Dr. Zach. The goal for today is to differentiate between an average rate of change and the instantaneous rate of change. Throughout this video, we're also going to discuss the expectations for the AP course. So, as you start looking through your AP Calculus lessons, what you'll notice is that they're generally broken up into 4 parts. The first part of your AP Calculus lesson is the lesson preview. You should complete the lesson preview before you begin the video for each one of the following lessons. Today's is a little different though. I have a small video clip for you to watch. Once you've watched the clip, stop the video that you're working on, answer the questions relative to the clip, and then restart your video. Please only spend about 10 minutes on this portion of your lesson so that we can get into our notes. So let's get started, please. Stop the video now and complete the questions. Now that you've completed the lesson preview, you should have a better understanding of the difference between an average rate of change and an instantaneous rate of change. So we're going to jump right in, and you should be asking yourself, what is calculus? Calculus actually has 2 branches of study. The first is average rates of change, and that's why you had your lesson preview. The second branch of calculus is all about area under a curve. Now, these are very intricate relationships, but you'll understand those relationships as we go through our AP Calculus course. So, average rate of change from your lesson preview, you should have figured out that it was delta y over delta x, which you also had when you were in Algebra 1. Now, from delta y over delta x, you then went into f of b minus your f at a over b minus a. So your information got a little bit more sophisticated as you went on. There were lots of variations for you to represent slope as you were studying algebra. But in Algebra 1, you studied lines, mostly lines the entire time. The best part about calculus is we're going to study average rate of change with curves and with lines, which is what makes it such an exciting branch of studying for mathematics. So as we're looking for the slope, average rate of change is still going to be from one point to the next. So in interval notation, x is an element of a, b, which means it's a closed interval and includes the points a and b. So on our graph, we have x value is a and we have an x value is b. So when you find the slope between the lines connecting a and b, that is called a secant line. So the slope of the secant line is going to be equal to f of b minus f at a over b minus a. Now, while your graph might have all sorts of fancy things happening, and it might be quadratic, it might be cubic, you can still just find the slope of the line, the secant line, to determine your average rate of change. However, it might actually become more important to think about instantaneous rate of change. So your instantaneous rate of change, when you're looking at your curve, is going to be the slope at just one point on the curve. But slope at one point doesn't seem to be something that we've ever worked with before. If I want the slope at one point, we're going to have to come up with some interesting ways to figure that out. So recall, all I know is delta y over delta x from my earlier explorations. And if I'm thinking about going from, let's call this point x1 and another point over here, x2, if I'm thinking about x1 and x2, and I could draw the tangent line, there's my tangent line, but what happens if all I want is to figure out the slope of the line traveling through x1. Well, as you can see, the slope of the tangent line is not going to be real useful. We're going to have to figure out some other way. What if we think about x2 migrating towards the point x1? That tangent line, the secant line, is then moving closer and closer and closer to our red line. Now, that red line is only touching at one point, and you know from geometry, a line that's touching the curve at one point is called a tangent line. So let's think about what we're doing here. We're taking our function from x2 and we're subtracting from x1. Those are your y values, change in y's, over our x2 minus x1, which still looks like the slope of a secant line. But the x2 is traveling closer and closer to that x1. So as x2 travels closer and closer to x1, wouldn't the difference between those two values tend to go towards 0? So x2 minus x1 is tending towards 0, and we're going to give that a little bit more sophisticated name. Let's call that delta x. So the change in x, well, wait, that's what we were using before, is tending to go towards our 0. Well, let's see here. If we were to use a little bit more sophisticated notation, maybe you had this in pre-calc, maybe you didn't. The limit as your delta x tends to go towards 0 for f of, now x2 is getting closer and closer to x1, and that's just going to be the x value plus some little bit extra, which we'll call delta x, which works out very nicely, minus our f of x divided by that delta x, which is tending to go towards 0. So hold on, this has a new name. This is the slope of your tangent line. As your delta x gets smaller and smaller, you're finding the slope of the tangent line. So instantaneous rate of change is the slope of the tangent line, and average rate of change is the slope of your secant line. And in order to find those two ideas, the slope of the secant line, you're going to need 2 points on an interval, and the slope of the tangent line, you're going to find instantaneous rate of change, or the slope at 1 point on the interval. But that 1 point is a little bit of a misnomer. You really want your delta x to tend towards 0. Does it ever touch 0? No, but it does tend toward the 0. The third part of our AP Calculus lesson is a lesson practice. You're going to take the skills we've been discussing and apply them to certain problems. In this particular practice, you have 3 questions related to a table of data about the temperature in Denver, Colorado. The 4th question is relative to the function f of x. For the first question, you were finding the average rate of change, which was 71 minus 68 divided by 15 minus 6. Of course, reduce your fraction when you simplify. The answer should also include units. So anytime you have units available, make certain you include them. So this would be degrees Fahrenheit per hour. For the second question, perhaps you found both of the values for the average rate of change. And when you had your both values, you found that one was 5 over 2 and the other was negative 11 over 4. Now, although negative 11 over 4 is a negative number, it is a faster moving temperature between the values 11 a.m. and 3 p.m. The reason that it is faster is because 11 over 4 is greater than 5 over 2. The negative sign does not matter when we're discussing a rate. For the third question, make certain that when you're looking for the instantaneous rate of change, that is actually the slope of your secant line, and that's a little challenging to find at 9. So what you might want to do is look at the 2 points on either side of the one that you're seeking. So perhaps you wrote 82 minus 69 divided by 4 to use as your estimate for the average rate of change at 9. And once again, you should be reminded to always write your answers using the units. So make certain you have degrees Fahrenheit per hour for questions 1, 2, and 3. For number 4, your average rate of change is going to be your f at 1 minus f at negative 5. Make certain you substitute correctly with your negative 5 divided by your 1 minus negative 5. Notice how you need to write the information down, then follow through with your subtraction and write your final answer. Now this one, of course, doesn't have units, and that's fine. The average rate of change from negative 3 to 4 is going to be done very similarly. So you'll take f at 4 minus f at negative 3 over your 4 minus negative 3. Now, just to get you used to it, average rate of change, write secant in front of those so that you have a reminder that average rate of change is talking about the slope of the secant line. For instantaneous rate of change at negative 3, we want to think of a number slightly to the left of negative 3 and slightly to the right of negative 3. So negative 3.0001 will be to the left of negative 3, and let's say negative 2.9999 is slightly to the right of negative 3. So notice I just chose some numbers. If you choose different numbers, that's fine, but we want to get as close as possible. So f at your negative 2.9999 minus f at negative 3.0001 divided by, and then do your subtraction and see what you come up with. If you come up with something just slightly different, it's really okay, because this is an approximation for the instantaneous rate of change. Doing something similar for 4 will give you an answer, once again, for the slope of the tangent line for question C. And for question D, I also want the slope of the tangent line, even though it's an estimate. So you should come up with slope of the tangent lines approximately negative 2 and approximately 7. But give those a try. Make certain that you're on target. At this time, I want to talk about the AP course. Please make certain that you read the syllabus so that you understand all the expectations for this course. By the end of the course in May, I do expect you to take the AP exam. And I not only expect you to take it, but I expect you to earn a 5 on that AP exam. You have a copy of the book, and also make certain that you have your graphing calculator with you at all times. I know that you're going to watch those lesson videos, and I don't want you to just watch the videos. I want you to listen to the lesson videos. Make certain that you're following the ideas and really engaging in learning. Now, once you have watched your videos, you'll be assigned some sort of lesson follow-up or homework assignment, if you prefer to call it that, one or the other. And the homework, do engage in trying to do each of the practices. You will not know how to do every single question, and that's fine. But spend 60 minutes doing the best you can. And if you have 1 or 2 questions that you want to ask, then please just send them my way, and I'm happy to chat about them with you. But make certain you are watching your videos, completing to the best of your ability the lesson follow-ups, and expect to earn that 5 in May. After that, we will be on the same page in terms of our expectations. So for the 4th part of each of your AP Calculus lessons, you're going to have a lesson follow-up. In this particular case, I'd like you to look at page 47 of your textbook and complete questions 1 through 5. Now, there are many copies of the answers for this book online, especially the odd ones, but if you go to Calc Chat, you'll find the answers, I think, to pretty much everything. So please, when you use a source such as Calc Chat, do the problem first. Once you've completed the problem, then check your answers and make any corrections. All right, this is the end of your first lesson in calculus, working on average rate of change and instantaneous rates of change. You have a great day.